Good morning everyone. Today my group members and I will be explaining about the topic called vector and Scala. But first let me introduce my group members. First we have Lalita Anaprapan Segaran. Next myself Mirosha Anaprapan Vitasala. We have Ilyana Izzati binti Muhammad Zaman, and lastly Shah Putri Rashika binti Selamat. In today's presentation, we'll be explaining about the scalar dot products of vector, the properties of dot products, vector cross product of two vectors, the area of parallelogram and area of triangle, and lastly a Q&A session.
Hello guys! So the main topic of our presentation is vector. As you know, in vector we have some subtopics. So today I wanted to explain to you guys about one of the subtopics of vector, which is scalar dot product of vectors. What is scalar dot product of vector? It is the scalar product or dot product of two vectors A equal to A1, A2 plus A3 and vector B equal to B1 plus B2 plus B3. For your information, we have two properties of dot products, which is in components and in geometrically. For incomponents, the formula is A dot B equal to A1 B1 plus A2 B2 plus A3 B3. We usually use this method when to find a vector in the question. In geometrically, we use this when we need to find an angle. So the formula is cos theta equal to A dot B per magnitude A magnitude B.
There are three properties of dot products. The first property is known as commutative law. In this law, you times in the vector of A and B together. For an example, the vector of A times B is the same and equal as the vector of B times A. Next, we have the distributive law of products with a scalar K. In this law, you times in the vector into the scalar of K and B, which is also equals to scalar K A times with B and equals to scalar K you times with A and B together. And the last property in this dot products is the distributive law over addition. In this law, you times in the vector of A with the addition of other vectors. For an example, times in the vector A to a B plus with C vector. So A times with B plus C vector is also known as A times B plus with A times C.
For an example, the question is, calculate the angle between the vector A equal 3i plus cj minus 8k and B is minus 2i plus 4j plus k. The solution is A dot B equal open bracket 3, 6, minus A close bracket, open bracket minus 2, 4, 1 close bracket. Next, the formula is A1 B1 plus A2 B2 plus A3 B3. Enter the number into formula. 3 open bracket minus 2 close bracket plus 6 open bracket 4 close bracket plus open bracket minus 8 close bracket open bracket 1 close bracket. After multiply, minus 6 plus 24 minus 8 equal 1. Magnitude of vector A equals square root x square plus y square plus z square. Next, open bracket 3 close bracket square plus open bracket 6 close bracket square plus open bracket minus 8 close bracket square. The answer of magnitude of vector is 109. Magnitude of vector B is square root x square plus y square plus z square. Next, square root open bracket minus 2 close bracket square plus open bracket 4 close bracket square plus 1 square. The answer on magnitude of vector B is square root 21. Cos theta equal A dot B over magnitude of vector A magnitude of vector B. cos theta equal 10 over square root 109 square root 21. Simplify. Cos theta equal 0.4474. Theta equals square minus 1, 0.4474 equals 63.42 degree.
So now we are going to see cross product of vectors. Given two linearly independent vectors A and B, the cross product A times B is a vector that is perpendicular to both A and B and thus normal to the plane containing them. So now we will be seeing how do we use the cross product formula. So there is two vectors, vector A and vector B. In both these vectors, there are three values in it. The first one, we consider this as I, the second one as J, and the third one as K. And we consider them as A1, A2, and A3. For vector B, the I value we consider as B1, the second value which is J we consider as B2, and the third value which is K we consider as B3. So next we need to find the value of I. So how do we find the value of I is we need to close the first row and the upper row which consists of I in it. So and then we are left with A2, B2, A3 and B3. We do the same thing for J where we close the second row and we close the upper row. And we are left with A1, B1 and A3 and B3. And then to find K, we close the last row and the upper row. And then we are left with A1, B1 and A2 and B2. And so next, after we put all the values in the formula, and then we need to find the determinant of value I, J and K. How do we find the determinant? We need to use the A times D minus C times B formula. And then we will get the final answer. Okay, so now we'll be seeing a question relating to the cross product formula. So the question says, calculate the cross product between vector A equals to 4i plus 8j minus 3k and vector B, negative 1i plus 5j minus 7k. So what we need to do first is we need to put all the values into the formula. And then we need to find the determinant for each. How do we find the determinant? Is we need to use the A times D minus B times C formula. So for an example, we need to 8 times negative 7 minus with negative 3 times with 5 in bracket I. So we need to do the same thing for J and K. So the final answer will be negative 41I plus 51J plus 28K.
Now let's take a look at the area of parallelogram and area of triangle. As you can see from the diagram, there are four edges, which is A, B, and C and D. So for the formula of area of parallelogram, the area is vector of AB times by to the vector of B and C. Where if you see the formula for area of triangle, you need to times with half, which is half times by the vector of AB times by half of the vector of BC.
So now that we know, we can find the area of parallelogram and the area of triangle by using the cross product method. So now we'll be seeing a question relating to that. So the question says, calculate the area of parallelogram and the area of triangle, which is formed by the vectors A equals to 3i plus 5j plus k and vector B equals to 2i plus 4j plus 3k. So next, we just put all the values into the formula by separating it into value I, value J and value K. And then we use the AD minus CB formula to get 11I minus 7J plus 2K. Okay, so next, to find the area of parallelogram, we need to find the modulus of cross product of vector A and vector B. So the cross product of vector A and vector B is 11I minus 7J plus 2K. So we need to square all those values, which is 11 square plus with negative 7 square plus with 2 square. So we need to be careful when you're pressing into the calculator. Make sure you put the bracket, because if you don't put the bracket, you'll be getting a different answer.
So the area of parallelogram is square root 174. You need to square root the answer after you square, and you will get the final answer will be 13.191 unit square. Okay, so next, to find the area of triangle, we need to times it with 1 over 2 square root 174, and you will get 6.595 unit square.
I have a question to ask. Why must times 1 over 2 when we calculate the area of a triangle?
Oh yeah, the reason why we times half when it comes to area of triangle, it's because the area of triangles is only half of area of parallelogram. So area of parallelogram is 2 times the area of triangle, hence why we use half when it comes to calculating the area of triangle.
Thank you everyone, and I hope our explanation made you understand the chapter a bit more.